I just think we did it in the previous problem. That's exactly what we did.
You guys are currently working on groups in this problem. Working in groups on this problem. I gave you a huge hint to try to help you avoid a very common mistake.
Oh no.
What was it, the thumb trick?
The thumb trick doesn't work. What was my huge hint? I said there are only two partial fractions. Which means, can this factor more?
No.
Some of you guys might have factored him more. Sorry, keep going, keep going. I just wanted to make sure you guys realize. Michael, sadly, the thumb trick is illegal because if you try to get zeros of this guy, they're imaginary. And another reason, because of the squared. Pause, check. We did not get an example of this yesterday, but I did write down what to do. If you ever have an irreducible quadratic, it was in the notes, that's why I had you guys open up your notes. If you ever had a quadratic, what are you supposed to put up top? It's okay, it's okay. Do you realize the difference though? These ones, the linear factors, put the A's and the B's and the C's. Even if there's a squared or a cubed on the outside, still, if it's linear in here, yeah. But as soon as we have one of these quadratics that can't factor anymore, we have to put not just A, but AX plus B. 1 degree less than the denominator. Does that change things a little bit?
Yeah.
Okay. Okay. But guess what I'm still going to do next, even though it looks funny and there's a BX plus C? I'm going to look at it and say, ew. What don't I like? What don't you like? The fractions. Ew fractions, remember? Ew fractions. So I'm going to get rid of them. Okay, keep going if you can. I'm doing the ew fraction step. Remember?
That one, yeah.
Let me give you a second. I'm doing the ew fraction step. I'm going to give you guys a little bit of time to try to do the ew fraction step. Lots of these. This is the orchestra, I think. They play like different movie soundtracks as like one of their concerts, and they have like clips showing on the screen and stuff. That's cool that they're still doing it. I didn't think after this month maybe not they still do it. Can I come back? Oh, you mean the x terms and the non-x terms? Is that what it's still a good idea to do like when x equals 0, x equals 1, x equals 2. That's probably the faster way. Yeah. Because you only have 1 0 that comes out, so you have to make up. Remember how we just said, okay, let's just choose 1 because it's easy? You could just choose 1 and 2, or 1 and -1, or 2 and 4, whatever looks easy to plug in. Jacob.
Could you just multiply by x cubed plus 4x instead of x times x squared plus 4?
You could. The problem is if you multiply that by this, it's going to be hard to see what cancels and what stays.
So how would the multiplication work when it's one outside the parentheses and one in the parentheses?
Oh, well, the cool thing is it's just like an over 1. So this will just reduce with that.
Right.
And over here, the reason it's nice I have it all written out is because I can quickly see what goes away and what stays. So it's not to a power, it's just little because it's hard to squish it all in. I'm multiplying like the big version, it's just squished in. So I'm just multiplying this side, which is dividing, multiplying by that, so it's all going to cancel. And I'm multiplying it over here and distributing it. Does that make sense? Have you guys figured out that 3x squared plus 4x plus 4 is left on the left? and ax squared plus 4 plus bx plus c times x is left on the right. Right? Double check the canceling out. But a is left with x squared plus 4, and bx plus c is left with just x. Now there are two ways to go from here. Okay? And since this one's a little bit easier to show than the one yesterday, which needed foiling, I'm going to show you both ways. And I think you guys are going to agree with me as to which way is easier. But one way would be to go ahead, and you can make it a different color. One way would be to go ahead and rewrite this whole thing. 3x squared plus 4x plus 4. And to say, hey, you know what? There's an x squared term. There's an x term. There are three different types of terms on the left. There are x squared term, there's an x squared term, an x term, and a constant. There are three very different types of terms, which is why they're not put together. On the right, if I distributed, I would have ax squared plus 4a plus bx squared when I distribute plus cx. And then I go ahead and say, all right, who are my x squared terms?
ax squared and bx.
Got it. So I could make from that that 3x squared equals ax squared plus bx squared. And if I divide everything by x squared, I actually end up with 3 is equal to a plus b. Then I could say, all right, who are my blue terms? The x term, the only just x, must come from that guy. So I could say 4x comes from cx. If I divide both sides by x, I know, well, 4 must equal, oh, I just got somebody.
Hello.
And last but not least, I can say, well, 4 didn't have an x at all, and who doesn't have an x at all?
Oh, wow.
Hey, some of you guys are like, wait. We know A, we know C. What can we do to find B? Go plug in 1. 3 minus 1, B is equal to
2.
Okay, why was this one so easy? Well, let me show you the other way. And then let's go back to the problem that we did yesterday and figure out why we chose the strategy we chose to solve it. So hold on, what did I do though? I said, okay, I had this big old equation, which would be very, very, very confusing if you just said, I don't know x, I don't know a, I don't know b, I don't know c, and I have one equation. I don't know anything. But I do know the x squared terms have to make 3. The x terms have to make 4, and the non-x terms have to make 4. So I can go steal the x squared terms, steal the x terms, steal the constant, and say, all right, I can figure this out. The other way would have been to use the thumb trick method. But I couldn't go straight to the answer because of this nasty squared guy. But I could still use the idea, like we did yesterday, and cover the x, guys. Who's the 0 of that guy? 0. So I could say, okay, when x equals 0. Now, if I go to try to cover this guy, here's where the whole struggle is. If I set this guy equal to 0, wouldn't I have to subtract the 4 and then square root? What's the dilemma with square rooting a negative number? I'm looking for real answers. We'll struggle. He didn't give me anybody. How many unknowns do I have, guys?
3.
3. X is just a variable that's in the equation. I have 3 unknowns, so how many x's do I need to plug in? 3. So why on earth am I randomly going to 1 and to 2 if I didn't get any other ones out of this guy?
Very easy.
I'm allowed to plug in easy small numbers. What happens if you plug in 0? Remember, plug it in everywhere. Well, 0 plus 4. Mental mathers usually like this way. 0 plus 4 is 4, 4 times A. 0 plus C times 0 is just 0. Oh, hey, sweet. Guess what you would have found this way also? A is equal to 1. Once we know A is equal to 1, what can we come back up here and do?
Plug A equal to 1.
Yeah, we could say, you know what, from now on, A is equal to 1. Now I plug in 1. 3 plus 4 is 7, 7 plus 4 is 11. Equals 1 plus 4 is 5, 5 times 1 is 5, plus b plus c times 1. I end up with b plus c equals 6. Oh, does that get me to an answer?
No.
No. But guess what I'm going to do and why I'm plugging in one more point? 3 unknowns. I need 3 equations. That got me straight to an answer. This gets me an equation with just b and c, and guess what's going to happen with this guy? 2 squared is 4. Do you guys think 2 is easier to plug in or negative 1?
Negative 1.
I might go negative 1 just to make it easy as far as multiplication, but just be careful the sign. 3 times 1 is 3, minus 4 is negative 1, plus 4 is 3. 5 times 1 is still 5. Negative b plus c times negative 1. So negative b plus c times negative 1. So b minus c, yeah. Which gets me to b minus c is equal to negative 2. Oh, I'm not to answers, but what am I going to be able to do right now? Little baby system of, can I do elimination and say, hey, my c's cancel. 2b is equal to 4. B is equal to 2. Sweet. Once I know A and once I know B, well guys, hold on, wait. Can't we just back substitute 2 in? So if we go back and plug 2 in, then I know 2 plus what is equal to 6? What must C equal? Do they get the exact same answers?
Yeah.
Yes. Yeah. To finish my partial fractions, to make, bless you, my final solution, which would be, let's see. It was over x, a, right? And a is equal to 1. And then over my x squared plus 4, I need to take the b coefficient, which is 2, whichever one I'm looking at. 2 times x plus the c coefficient, which is 4. If you guys were to get common denominators between those two, where would you end up? Right back at the beginning. Now, 2 different ways of solving, both very, very valid. How many of you guys like the left-hand side as far as grouping up the x squareds, the x's, and then the constants and solving? Cool. How many of you guys like the mental math, plug and chug, play around until you get it? Okay. On this example, I thought most of you, when I first went into it, would like this one better. But didn't this end up pretty easy? Here's the question. Why then yesterday, when we had that kind of hard one, remember the nasty one, where we had the long division, then we had this part left over, then we had to take this part and split them down, why do you think I didn't do it this way? I'm going to zoom in. I'm asking the question, why yesterday? Because I agree with you. I think the left-hand side was probably the easiest way today. Why yesterday did I not go this route? Let's go ahead and peek at it, okay? If I zoom in, there we go. We did that division first. We got down to this statement right here. Got our common denominators and got here. Why do you think I didn't go, hey, x squareds, let's go looking for them. X's, let's go looking for them. Constants, let's go looking for them. Michael?
There's no constant.
There was no obvious constant. That's true. Can anyone figure out why there's no obvious constant and where the constant really is? And that's kind of the reason why I didn't go that route. Where is the constant? It's not there. That has an x. It's not here because that both has x squareds and x's. Where's the constant?
The A1, the A.
But what do you have to do to get to this guy?
Point.
FOIL. So let me quickly just, I'd love to have it on the video. Let me go ahead and dual screen real quick. Nope, let me do this instead. Pause, give me 1 sec. Come on. Let me steal this part right here, because this is what we were looking at. Actually, no, let me steal. Yeah, I'll steal this part. The 6 and the 9, sadly. I know, Lo siento. The 6 and the 9, sadly, we only got after we did all the work of choosing let x equal 0, x equal -1, then we chose one more. So technically, we wouldn't know this at the beginning. That was something we added in later. Let me show you really fast what would have happened. You don't even have to copy this down, but let me show you what would have happened. We would have had our 5x squared plus 20x plus 6. if you had FOILed properly and not killed any poor little puppies, and distributed the A, you would end up with ax squared plus 2ax plus a plus bx squared plus bx plus cx. Then you would have had to say, okay, let's go find all the x squared terms. Let's go find all the x terms. And let's go find all the constants. Oh, maybe it's not too bad. What do you guys see? I could do the 5x squared equals ax squared plus bx squared, but do you guys get what I did in the other example and just took away all the x squareds because I divided? So really I could just say 5 equals
A plus B.
Then I could say, from the, who am I doing next, the x terms? 20 equals what?
2x plus b plus c.
You could write it with all the x's, but what would happen as soon as you divided, they're all gone. And then what's my last one? 6 equals a. Oh, hey, we got one. Now what?
Plug it into
Plug it
5
into the
squared.
green.
Oh, sweet. Okay, so then I can plug in 6. Then b is equal to,
-1.
now I can say, sweet. So a equals 6, b equals -1. Okay, I just rewrote it. So we have to do, okay, 20 minus 12 plus 1, that'd be 8. 8 plus 1 is 9.
Bam, that's easier.
Some of you might still like this process better, but pause one more time. In order to even get this right, what did you have to do first? FOIL properly, correctly, and then start matching up. Now, once again, is this process bad? No. It's sometimes easier, and some of you are like, I like it better. It makes more sense in my head with the x words, the x's, and the, rather than doing this weird, like, picking random x's, kind of not random x's. Mental mathers, you might love this way because you're just plugging in numbers and then figuring out what you're left with. But those of you that are a little bit more algebraic and a little bit less mental math, this is a great way of organizing and solving. Okay? Are either ways good? Yeah. Do both ways get you the same answer? Yeah, take it.
Can you show the work for the FOIL that you did?
Oh, yeah. The work for the FOIL that I did,
A times x plus 1 squared.
because most of you, it'd probably be a really bad idea to mental math that. You would need to do A times, just in case the shortcut that you learned back in Algebra 1 doesn't work, shortcut being square the first, square the last, double the outer inner. It's a nasty shortcut in my mind, but it does work. You could have rewritten it and gotten x squared plus 1x plus 1x, which is plus 2x, and then plus 1. Then I would have distributed. Then we would have brought that A in.
Okay.
Okay, both ways good? It's up to you as to choose which way you want to go. Questions statement, as of right now, you have officially seen for this section all of the different types of problems that can come up in a sense of, as of this morning's example, the one that you guys started in the back of your spiral, not only did you get to see both methods for solving by partial fractions when it gets kind of messy, you got to see both methods, but also you got to see what do we do with this nasty little quadratic guy, okay? Because some of you didn't catch up in notes last night and watch the video, and because some of you got stuck because you weren't able to kind of see all of it put together at the end of class yesterday. If you guys look on the back board, I don't have homework 45, section 7.4. I don't know how we got to 7.6 all of a sudden. I don't have homework 45 still up here, but in a way it's still understood, because what did I still have as finishing today? Yeah, I had final practice on 7.4. Let's grade this homework tomorrow. Gives you guys a night of grace in the sense of finishing up or moving past, hopefully, where you got stuck last time. Sound good?
Yes.
Okay. And for those of you guys that were gone, you get to kind of catch up. Here's a page which maybe some of you want to take a quick picture of it and write it down later. I don't know if you necessarily need this page, so I'm not going to give you guys time to write it in class. But if you want to peek at it, what it's saying is, you know what, here are some ideas that you can do. You can do the thumb trick method of finding the zeros of the factors and plugging in. For repeated linear factors, you have to write them multiple ways and maybe substitute other convenient values like we did yesterday, picking the 1 because it was easy to plug in. So it puts into words what we did as far as plugging in the zeros and then, running out of zeros, and so picking other convenient numbers to plug in, like small ones. This one for quadratic factors. For quadratic factors, they say expand, which would be the foiling. Foil it all, collect all the terms, the x squared terms, the x terms, the constant terms, and then use a system of linear equations. So it kind of just says, hey, you can do this whole collect the terms thing, which is my color coding thing. Or you could plug in the zero. So I'm just saying both of them are valid, both of them are good. That's kind of what this whole page is saying in words. So once again, if you want to look at it, if you want to write it down, if you want to think through it, some of you are better with words than math. It might help just a little bit. But let's, can you guys just help me? And I think you guys had a couple of these in homework, didn't you? Can you just find or set up the partial fractions for this guy, which means don't solve all the way. Don't solve all the way. Some of your homework says don't solve all the way. We can just do this together. If you want to put it in the back of your spiral, you can. If you want to put it in your notes, you can. We're not going to solve it all the way. Sometimes it just wants to know that you know what direction to go. You guys figure out how many partial fractions we make for this guy? Wait, pause. Improper or not improper? I know exactly why you said that, but you're wrong. Improper. Oh, look, top wins!
No. Square.
If I were to actually write it out in FOIL, this isn't an x squared, it's an x to the fourth. Now, if I FOILed it, it'd be x to the fourth plus 4x squared plus 4. Not killing a puppy, but it's still an x to the fourth, so who actually wins? Okay, I don't have to divide, which is a good thing, right? I don't have to divide. A question, do I really need to factor either? No. Because, can I factor x squared plus 2 down anymore? Check it. Are there zeros? No, they're imaginary. Square root of negative 2 doesn't work. There aren't any zeros, so I can't factor. Oh, that is factored. How many partial fractions? 2. What's in the denominator?
X squared
plus 2.
Can you guys use the idea of repeated linear factors to apply it to repeated quadratic factors? What's going to be the next guy?
X plus 2. That's what.
Okay, we don't write the same thing twice. There are 2 factors, but we don't write the same thing twice. Some of you missed this yesterday. If there's a repeated factor, we need to write it to the first power and then build up to the second power. If this was cubed, guess what? There would be 3. What would the next one be? This, then this, then the cubed one. If it was to the fourth, there would be 4, and you keep on going to the fourth power. Now wait. Use what we did today. If there are squareds that can't be factored down anymore, we call them irreducible. What goes up top as far as our unknowns?
X squared plus b, and then what's after?
Ax plus b, and?
X plus b.
Got it. That's enough for this problem as far as setting up. But can you guys tell me what, in words, what you would do next? Look at it and say, ew. Get rid of the fractions. Multiply both sides by? Right? Then you would get an expression on the left, stuff on the right. If you like the color coding, separating it all up way, FOIL everything. Find the squared terms, find the x terms, find the constants. If that starts looking really disgusting to you, oh well. Plug in. Oh, I don't have any zeros. Plug in convenient values. Who's usually easy to plug in? 0. Who else is easy? 1. Oh, wait. Just a hint, you're going to need 4.
-1.
Negative 1? 2. Okay, fine. 0, 1, negative 1, 2. Why not 10, 17, 37? Because we don't like mental math that much, right? But could you have? Yeah. Just, this doesn't sound fun. Just a hint, for those of you guys that are like, hey, let's FOIL and solve it all. Maybe it would be pretty easy to do the squares and that, but the problem is, you're not just gonna have squares. 3. You're gonna have cubes too, and maybe 4th powers. Maybe you're not gonna like that system after all on this one. Anyway, just a hint as far as how to set this guy up. Once again, we'll look at questions that you have on homework tomorrow. Just in case you do get one of these nasty ones, you know how to start it, and we'll see if you can finish it. Jacob, go ahead.
Is that CX plus 1 on the top, or is that?
Oh, plus
one?
D.
Oh,
So we just kept going with the variables to expand it out. Leo.
I'm so confused how'd you get the denominators for the...
Oh, it's actually back here in notes from yesterday. So if you watched the video from yesterday, it might help. We looked at the idea that sometimes you might have a repeated factor, and so you have to build up the first degree, then the second degree. And then we had an example actually where I think it said repeated linear factors on this guy. You didn't see it right away, but as soon as we factored and we got this squared, then we covered again how you have one for the x plus 1, but you also have one for the x plus 1 squared. So we just applied that idea to that little quadratic guy,
Okay.
wherever he is. It's frozen. Go team. All right, guys, notes open, section 7.5. We got to start it. It's still frozen. Yeah.
For the one we just did, to get rid of the fractions, it would be the same as we always did, right? Like,
Yes. Yes, the same as we always did. Oh, praise the Lord, thank you. I'm going to save this real quick before we lose everything, because the computer is not happy right this second. Don't ask me why. I don't know. Perfect. All right, our goal today is to start 7.5. Tomorrow it's to go over questions to 7.4 and to finish 7.5. There is a section 7.6 that we're actually going to be skipping for a couple reasons. Some of it might be our skill level, some of it might be how behind we are. We're gonna skip 7.6.
good, thank you.
And if you guys haven't checked out the backboard, the reason I'm telling you about what's going on the rest of the week is because it's actually on the calendar, but there's a test on Friday. You are not getting back your chapter 6 test before because it's going to be your homework probably over the weekend and into next week to do corrections. So we're just getting through this test first. I don't want to distract you right before the test with corrections on vectors when this chapter is very, very different. But for a lot of you, it's also very, very straightforward. 7.1, substitution. 7.2, elimination. 7.3, okay, kind of weird, the stair-step row echelon, but there was a system to it. Solving larger systems of equations. 7.4, the partial fraction thing that we worked on a couple of days now, but once again, a very clear systematic approach. And you can kind of choose the way of solving that works better for you. Figure it out in homework, which way works better. The color coding, splitting up the different types of terms, or plugging in x is 0, x is 1, x is 2, and solving that way. So the only thing that we haven't learned is 7.5. We're taking today and tomorrow so that we can just totally skip 7.6. In years past, 7.5 would have been today. 7.6 would be tomorrow, and then you'd have even more to learn. I decided that's not a good idea for us. Figured it'd be better. All right, then let's try to get a good idea of 7.5 today. Last section on the test. Hopefully doesn't add too much. Skipping the last section in the chapter. As you guys are writing, just a few of you are seeing two different things. One of them is the word shade, not throwing shade, but shade, and then the other one is, y is greater than or equal to? Wait a minute, you've been here before. Dotted versus solid, above versus below, shading graphs. finding overlaps. Hey, if you have colored pencils,
This is shady.
or if you have highlighters, or if you have different colored pens, etc., you might want to grab them out now because it's going to be helpful for today. You probably don't need more than 3 colors, maybe depending on. Some of you have lots of colors, some of you are like, well, my black pen, my pencil, and my blue pen. Hey, that works. It's okay. Do what you gotta do. But for those of you that have all kinds of fun stuff, there we go. You can grab out some colors because it might be helpful. Systems. Systems of inequalities. Before we can review that, we just gotta review inequalities. And as you guys are writing, don't write this example down, but inequalities, the very first types of inequalities you learned was something like, hey, x is greater than 4. You would have done a number line, and you would have put something like 0, 1, 2, 3, 4. You would have put an empty circle at the 4 and said, hey, it's all the numbers above. You guys remember that? Greater than can't be at 4, so we leave it empty. Not or equal to, and then above, all right. If it was less than 4, we go the other direction. Maybe you would have more than one of those, trying to find something like maybe the intersection or the union. You could have x less than or equal to 5, so you would put the 5, you would have put a solid going back. If you had to put them both together, maybe with a word like and, then you would have said, oh, put these both together, where's the overlap? And the overlap would be from here to here, connect. But this equation's a little bit more complicated than just a number line because it doesn't just have x's. What else does it have?
Y.
Exactly.
Why?
Was it a question or was it a variable? Anyway, so has x's and y, which means, all right, no big deal. Just like the original one I just showed you, x greater than 4. The first thing we do is get the 4. All right, well, on this one. Y greater than or equal to x squared minus 1. The first thing we do is get the x squared minus 1 on the graph. All right, cool kids, x squared minus 1. Who is that? Pause, give everybody a high five in your group. It's a struggle. Again, it was yesterday. It's a struggle again today. You get to color, guys. It's exciting.
You hit my face.
I died.
We make everybody up?
I think Joel's still.
Come on. Look at you. We're supposed to give him a high five. How is he not awake right now?
Joel.
Yeah, I'll give him a high five.
Get me away.
I was asleep.
They were supposed to give him a high five. I was trying.
No thanks. Get me away from her.
She slapped him in the face.
But when you put it like that.
Here we go.
So excited.
Joel, he's color today.
Oh, yeah.
Yeah. Hey, kiddos, what's the very first thing? I just said it before I opened the door and tried to get you guys all awake. What's the very first thing we
X
graph?
squared minus 1.
Who is x squared minus 1?
It's a
Parabola.
big
A parabola that's been shifted down. All right, get him on there. Are we going to sketch and be approximate? Yeah, we are.
Yeah.
All right. Why did I graph him x squared minus 1 with a solid line?
Because
We always do.
it's greater than or equal to.
We always do with an equals. So what did you see in this one?
Greater than or equal.
Equal to. Okay, with an equals, we always do a solid line. What if that was missing?
It would be not done.
Then it would be
Then we do the little like, we do the dotted and the dotted and the dotted and the dotted, right? All the way around. Oh, I missed him. Okay, but what is it not? Dotted, because what is there? The equal to. All right. We are not done yet because that would just be y equals x squared minus 1, which we technically would call the boundary. This is the boundary line. So if this was your team, everything greater than or equal to x squared minus 1, where would be all your people? Where are you shading?
Inside.
Inside. Now if you're kind of like inside and not like inside, you're not very confident in your answer, how could you know for sure?
Use the mouse.
Test 1.2.
Sure, now you're all just jabbering. Okay, so coming back.
Shade.
Shade. What's a point that's where you think we should be shading? Any point.
0, 0.
Ah, nice. He's super easy to choose. So test the point 0, 0 and say, okay, if I was to test the point 0, 0, I would plug in y is 0 when, x is 0. I have to just ask myself the question, true or false?
True.
I say true.
0 greater than or equal to -1?
Yes.
Oh, yeah.
Since it's true, was your original supposition of coloring on the inside correct?
Yes.
Yeah! 0, 0 works, so guess what? If 1 works, all of them work.
Wrong.
Done, 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 done. Just kidding. Done for this problem, not done for the section, because the section doesn't say inequalities, it says
This system.
this was not a system because it only had one, which is why you should have multiple colors on your desk right now. What if we have 2 or 3? You guys got the example? Alright. When you start color coding. When you start color coding.
Black, and copper.
But right before we do an example, does it make sense that I'm warning you, system of inequalities, there will be more than one? Solution, a point that satisfies every single inequality, not just one. So what are we going to do? Take each one, sketch them individually. Color coding would be a great idea, yeah?
Maybe.
Not factorial, just exclamation point. Find a region in common, aka find the
Solution set.
solution set, which I'm going to call, just to be, I don't know, simple, I'm going to call it the overlap. Where do they all overlap? Now, okay, hold on. There's one extra little piece that maybe isn't quite so common sense. There are multiple inequalities. Graph them all, color code them, find the overlapping region. You guys have seen that since Algebra 1, to be honest, but Algebra 1 you were probably only doing lines. Now we could be doing parabolas or other interesting circles, I don't know, other graphs as well. But this whole vertices of the solution region, I'm going to put in quotation marks underneath vertices the corners. The corners of the overlap. Now sometimes the overlap goes on forever, so there are no boundaries that completely hem it in or completely hold it back. Sometimes it goes forever in one direction, so there'd be no corners out in the infinite, out in the forever. But if there are any boundaries that's holding it back of multiple systems, or multiple, I should say, conditions or solutions, they're going to be found, or they're going to be located at the corners, and the corners are going to be found, are going to be able to be solved for by the intersections. The intersections between equations, or I should say inequalities, because they're not just equations anymore, in the system. So, when I say the word vertices, what I'm talking about when you're looking at it is the corners of whatever the overlap region is. And what I need you guys to be thinking, if you need to solve for them by hand or even with your calculator, if we're able to use it on that, you're going to have to be finding those intersections to find those corners or those vertices. So that's basically the newest thing, besides all of a sudden expanded on from Algebra 1, we're not just doing lines anymore, not just linear inequalities. It could be other inequalities also. We're pretty close? Have our colors ready? Anything crazy outside? Mark, set, and? Alright. My first one's going to be my red one. Second one's going to be my green one. Third one's going to be my blue one. Some of you are going to hate this example.
No.
But it looks so easy.
But it is not.
How do you even go back to the first one?
Let me go back to
And then multiply it by the negative one.
It's a line. So Lainey's telling me get y by itself.
Correct.
Because if I get y by itself, then I see the mx plus b. So maybe I'm not gonna graph that guy, maybe I'm gonna graph instead, why am I gonna get y greater than x minus 2? When I subtract the x and I divide by the negative, multiply or divide by a negative, yep, it's gonna have to flip.
Uh-oh.
But now that I have my x minus 2, can't I just say it's a line with an intercept of negative 2
Yes, ma'am.
and a slope of 1 over 1, yeah?
Yeah.
So up 1 over 1, up 1 over 1, up 1 over 1. Ooh, that's a nasty line. Pretend I actually did that somewhat evenly. Why am I doing this guy dotted?
Uh-oh.
There's no equals, right? Now what am I gonna do? Wait!
Do the next
Wait,
one.
no.
Where did I shade?
You should
Shade on the wrong side.
And what's the inequality show?
Greater.
The greater.
Okay, because we had to flip the sign with that negative, right?
On the top.
So then, shade above. If you had any doubts as to whether your shading was correct, what could you test? 0, 0. And guess what? 0, 0 works. Okay. Now, I got this guy. She keeps on going forever. But I'm not done. Who else do I need? X is negative 2. Doesn't that happen at that little tick mark where x is negative 2? Right?
Yes, it does.
But it's just 1 point? Nah, follow the tick mark. Isn't that a vertical line? I know, that's why some of you guys might not like this guy.
Everybody watch out.
Because you have to remember, vertical lines and horizontal lines too. Why is he counted?
Because he is not equal.
Not equal.
Shut up, you're not equal.
Which way am I shading? If x's need to be higher than negative 2. Negative 3, negative 4, negative 5?
To the right.
To the right.
Oh, too many.
We got some overlap.
But I'm still not done. What else? Now we have 1, 2, 3. Y equals, isn't that a vertical? No. Horizontal one?
Solid.
Why is it solid?
Because it's equal to.
Where am I shading?
Under.
Is this getting pretty messy?
Oh, yeah. Oh, it made a triangle.
What should I advise you to do? Get a fourth color
Does it change? I need another
Great, guys.
to then be able to show exactly what the overlapping
Like the only
region
That's right.
is.
You have to find what that is, or you just...
Wait a
Color it,
second.
and then it made a triangle. I don't know if
Oh, that's it? How does it sound?
Pause!
I found it.
Pause! Where are the vertices?
Excellent question.
The corners, which are the intersections. Finish up 7-4, maybe even start 7-5. I'll see you guys tomorrow. I guess we're watching.
No, my dude, I have a AP physics That's all I got. Oh, never mind. No, I'm not.